Okay, I'm going to take you through the use of my freeware image processing program, ImageJ, to have a look at the original files from that generated the image that has subsequently been faked. So ImageJ is one of several image processing programs you can use to import image sequences that are taken with cameras. Here I'm going to import a sequence. These are 4 images that I've taken using the iTelescope G5 instrument back in 18th of September 2010. I'm now going to import the original FIX files. These are the raw image format files that come out of the telescope. You can see the original images here. There's 4 of them in a stack. Note that the position of the stars move a little bit when we between each image. As I set this up, the telescope refocused and repointed each time, so it's a little bit different. So we've got our 4 individual images taken by the telescope. Each of these taken for 90 seconds. Now, one of the first things we can do is, because these are FITS images, they have a large amount of information on the actual image, embedded in the image itself. So what we're going to do is go Image, Show Info, and there you go. This shows you all the information that's embedded in these images, the name of the file, sample rates, which aren't so interesting to the people, but of course here's the most important part. Here's observer, Ian Musgrave, that's me. The time it was actually taken, 18th of the 9th, 2010. If you zoom down to here, you'll have the location RADC of where it was pointed, which is pointing nowhere near Leo. I'll show you that later on. Okay, so that's the image and the image header. So let's just zoom into the image for the moment, and I'm going to apply an auto to the image just to pull out the image brightness. And you'll notice a couple of things. As I'm moving the image around, you'll see that there are a couple of bright dots that don't move. These are hot pixels. These are sections of the CCD camera which are permanently on, and you'll also see a couple of things flash on and off as cosmic rays or stuff hit the CCD camera. But the most important thing is we see 2 things. We see that the stars are move slightly with respect to each image against the fixed points of the hot pixels on the CCD. And if you look over to the top left, you can see the comet 103P Hartley 2 moving between each image. This will be important later. So I'm going to crank the image up a little bit, and what I'm going to do now is I'm going to align these images on the stars. You can align them in a couple of ways. You can align them on the comet, which brings out the comet quite nicely, or you can align them on the stars. I'm going to align them on the stars just to replicate what I did in the original image. So we go with ImageJ, we go Analyze, Plugins, register a region of interest, which we're going to do in a moment. But before we register a region of interest, we have to select a number of stars that we're going to register. I might make this area a little bit bigger. Okay, and now I go back to plugins, register ROI. We'll start registering the image on top of each other. Plugins are a very potent feature of this. Now you can see as we move between the images, the stars don't move. We've managed to align the images on the star. and you can see the stars twinkling slightly between the exposures. This, of course, is due to turbulence in the atmosphere. Okay, now, the reason why we take multiple exposures is so that we can stack the images one on top of the other. I'll now do this. You'll see image stacks. We've put the images into a stack, and we can create what's called a Z project. And the Z project here, we're going to sum the slices, all the slices, and so this will add all the images together. But this will bring out fainter objects. We're going to zoom into the comet area. Now, if you're familiar with the photo that's being touted as being of an actual planet, the crescent object is supposed to be here. Now, I've really brought out the brightness of the stars and the comet, and you can't see any crescent whatsoever there. I'll just zoom in a little bit more, and you can see nothing whatsoever. I'll bring up the intensity even more until we start seeing the spikes. And you can see that you can't see anything in there. Let's reset it. Go to auto. Oop. Okay, we'll just review this again, set it to auto, and I'll mess around a bit with the maximum, minimum contrast just to pull it out a bit more. Increase the brightness and cranked up the contrast a bit so we can see. You can see now the diffraction spikes. These are artifacts occurring within the camera system. So that we can most interestingly see that the diffraction spike goes across the area where in Don's image the alleged planet was supposed to be, but you can see quite clearly there's no planet. You can also see this series of dots here. This is the hot pixels, which I showed you before in the original images. In the original images, they're all in the same position on the CCD cam, but because the pointing of the telescope in between exposures has changed slightly, when you stack the stars on each other, the hot pixels are smeared out like this. And again, there's the comet. Notice the comet is pointing away from where, in the original image, the bright illuminated part of the crescent is pointing downwards, and we know that the comet tails point away from the sun, so the sun must be pointing up somewhere over here, so the crescent comes. I'm going to zoom in a little bit now. Again, you can't see very much happening here. I'll zoom back out again. And if we want to, I can now crop this image, but you can see this is now at the same scale as the image that has been presented. I'll bring that up now. You can see quite clearly that this is exactly the same image. It's a bit pixelated because the image is scaled, but this says 89 Leo, taken on the 1st of January 2012, and as we saw from the headers, this has very clearly been taken on the 18th of September 2010, but they're exactly the same image. The most important thing here is the comet. Notice the comet. So it's slightly different in these ones because I used a different stacking process in the image I initially posted on my website to here, which emphasises the tail more than overexposing the head. But the main thing is that these are exactly the same thing. You can't. The comet has moved long ago. 2 years ago, the comet was here, but it's now nowhere near this position. So this image cannot have been taken in 2012 because the comet's nowhere near there. It can't be in Leo because the comet was never, or near 89 Leo because the comet was never near 89 Leo.